Okay, last one. This is example 5. At what value or values does the graph of h of x equals 1/2 x squared times the square root of 4x plus 3 have a horizontal tangent? So functions have horizontal tangents when the slope of the tangent line is 0, right? That's how I get a horizontal line. So I'm wanting to identify when the slope of the tangent line is equal to 0. And so I basically just want to say, okay, well, the calculus term for a slope of the tangent line is the derivative. So I'm really looking for where h prime of x is equal to 0. So first thing I need to do is I need to find h prime. So h is a product. I have 1/2 x squared times the square root of 4x plus 3. So I need to do product rule. My first function is 1/2 x squared, and then the second will be 4x plus 3 to the 1/2. That makes the derivative simpler. So when I first multiply by the derivative, okay, so we would have the first function, which is 1/2 x squared, and then times the derivative of the second. Now, in order to differentiate 4x plus 3 to the 1/2, I have to use chain rule. So I'm going to do the derivative of the outside function, which is stuff to the 1/2. So I'm bringing the 1/2 down front, leave the inside, subtract 1 to get negative 1/2, and then times the derivative of the inside, which would just be 4. Then I need to have plus the second function, so 4x plus 3 to the 1/2, times the derivative of the first. So the derivative of 1/2 x squared would just be x, because I'd bring that 2 down, and 2 times 1/2 would be 1, and then 2 minus 1 is 1. So I end up with just x. Now, the rest of the problem is just solving for x. Now, solving this equation for where this equals 0, but in order to do that, I need to simplify this a lot better. So, the way that I need to do that is I'm going to work on this first set of products first. I took all the coefficients, 1/2 times 1/2, which is 1/4, times 4 would give me 1. So now I just have a 1x squared up in the numerator, and then this 4x plus 3 was to the negative 1/2, so it got dropped to the denominator, and I rewrote it as a radical because that might be a little bit easier to deal with. Then I have plus, and over here all I did was I rewrote that 1/2 as a square root, so they were both consistent. So now to solve this equation, I can subtract that x square roots of 4x plus 3 to the right side. So I now have x squared over the square root of 4x plus 3 is equal to a negative x square root of 4x plus 3. To get rid of my fractions, what I'd like to do is I'd like to multiply both sides by this square root of 4x plus 3. So if I multiply this side by square root of 4x plus 3, then I need to multiply the right side as well. On the left, those are going to cancel. On the right, square root of 4x plus 3 times the square root of 4x plus 3 is just going to leave me with 4x plus 3. So I then have x squared left equals a negative x times 4x plus 3. I can distribute the negative x through on the right. Then I'm solving a quadratic equation, so I want to get all of the terms on one side. So I added a 4x squared and I added a 3x to the left side. I can then factor out an x, so I have x times 5x plus 3. And then I set both of those terms equal to 0. So if we set both of these equal to 0, then we have x equals 0. And then if we solve 5x plus 3 equals 0, we'd have x equals negative 3/5. So we want to justify our answer, so we'll write a nice sentence that h of x has horizontal tangents when x equals 0 and x equals negative 3/5, since this is where h prime of x equals 0.